Welcome in everybody to our sixth episode of Tofu Tech Talk, and I have a wonderful guest with us today. This is going to be our first mathematician on Tofu Tech Talk, which is really exciting. And yeah, would you like to introduce yourself?
Yeah, sure. My handle is Enstucky. You can call me Stucky for this conversation. Um, I and yeah, I run a math variety stream here on Twitch, called the Mathematical Creature. We've been doing all sorts of stuff, and I never really know how to describe exactly what the nature of the stream is. But it's
That's how
been
I found you, yeah. I was just looking at science tech streamers and I found someone who's not doing programming and, actually streaming something. So yeah, it was very hard because you cover some really advanced mathematical stuff. So if anyone wants to give Stucky a follow, you're more than welcome to, but just be prepared. They're super smart, like way smarter than the stream. So just bear with me. But yeah,
I don't.
so you're a mathematician. You have a background in what kind of area of maths?
Yeah, so my PhD was in algebraic combinatorics, which means, I mean, if you just want fancy words, there you go. But combinatorics is comes from the same root as combination. So it's the study of combinations, or the more broadly interpreted as the theory of counting. And algebra means that like there's some symmetry involved. So I like to count things using symmetry.
Wow, I understood everything. Feels good, man. Okay, so would you like to start off by talking about your research a little bit? Are you allowed to, by the way? I don't know if you've published your
Oh yeah.
work or okay, just making
Yeah, there
sure.
are no trade secrets in pure mathematics. Um, yeah. So, I, so I don't know. I don't know exactly how to start this conversation,
That's
but
okay.
yeah, I spent a lot of time focusing on these things called reflection groups, which are essentially, I say I like to do things with symmetry, so essentially, I like to think about reflection symmetries in high dimension. Um, and somehow we're supposed to understand um, that the process of like rearranging, um, you might have come across the words permutations before in your mathematical life. These permutations um, are can be understood essentially in precisely this way.
Hmm.
Um, and it turns out that this is not the only way that you can do that you can sort of make finite groups in high dimension. Um,
Okay.
and so I was really interested in doing sort of counting stuff that was related to these other ways of thinking about reflections. That's
Okay.
that's sort of the high level, no details version.
Oh no, yeah, okay. I don't think I keep up with that, and I can keep up. Bear in mind that you are speaking to someone who doesn't know mathematics, like because we do discuss this, and you've been on my stream before, and we've mentioned that mathematics and physics, like pure maths, is scary. It's not really. There's like some scary philosophical and debatable kind of topics, if that makes sense. So there's almost a lot more words than you expect. Is it right to say that
Yeah.
in your PhD there was actually a lot more words in your thesis than there were equations?
Oh, certainly, that's true.
You would
And
think.
I'll throw it right back at you. I think that theoretical physics is also terrifying. So like we both have a mutual fear for for each other's disciplines.
Oh no, it's a good thing I'm not theoretical physicist. I was an experimental,
I
so
mean,
that
yeah.
explains why. That explains why everything. Okay, so yeah, a lot of big words there. Jimmy asks, so does that play into the premise of different sizes of infinity? Um, was that you discussing? Um, what was the word you said? There was a word you said. My brain is lagging.
Like permutations, like
Mm.
reflections in high dimension,
Yeah. So how does
something
infinity play
associated.
into that?
Yeah, so typically, like the world of math, sort of stereotypically, I guess, is divided into these like two sides, the algebraists and the
And
analysts.
they call it
And
a
so I very
mind
much fall like if you have
of
to put me in one of these camps, I
might.
very much fall on the algebra side. And generally, the people who like to think about infinity live on the analyst side. So I try to avoid infinity as much as possible in my like day-to-day mathematical life. Although certainly, yeah, there is some cool stuff happening there, and I'm glad it's around. There are people who take this philosophy like really seriously. Even going so far as to say like even the idea of an infinite thing doesn't make sense, and that can get really bizarre really quickly. So I like to keep a healthy medium, but like in my day-to-day life, I try to stay away from it.
So you try not to touch the topic of infinity.
Yeah,
I
I
know
guess I
it's
should say it in my like research life. Um,
so, but I suppose I know this is really the topic that we were kind of planning on discussing or anything, but the whole point of a podcast is to just go
of
with it.
course.
Infinity is a huge topic in theoretical physics and in just physics in general. As a person, I'm sure you know from calculus, limits from infinity to zero is a very standard thing to clean up equations. It's a cheat code, the premise of it in physics all the time. But is there is there debate in maths about the concept of infinity, or is there a general consensus of what infinity is and what it is defined as in maths?
Yeah. So conceptually, infinity is understood in like several different ways in math, and so I think that can be a little bit misleading to folks who are not in the discipline. Like it sort of feels like there's a debate, but it's really just like different ways of understanding this concept.
Okay.
But there is very much there are very like actually thorny issues uh and like unresolvable by formal means. One of the classic examples when you're first learning about infinity, like the mind-bending counterexample, is that there are actually as many like fractions, like rational numbers, as there are just whole numbers. Right?
Yes, yes.
Um,
So there's
and
more
so
number. Sorry, just to in case I knew that there's the same amount of numbers. Or is that what you're
there's the
saying?
same amount, yeah.
Between 0 and 1, as there is 1, 2, 3, 4, going all the way to infinity.
So you have to be a little careful.
Oh,
Only fractions. Yeah. So if you're allowing yourself like pi, okay, pi is not
yeah,
between
pi.
0 and 1, but whatever,
Okay,
right?
yeah,
If you're allowing yourself irrational numbers, then there are actually more of them. So that's like the second counterintuitive thing. Like the
yeah.
first counterintuitive
What?
thing is,
Oh
yeah,
wow.
the first counterintuitive thing is that actually, like the fractions are the same size, and then you're like, oh, well, probably every infinity is the same size, but it turns out that's not true either. Um, but there's a very subtle question called the continuum hypothesis, which asks, are there any infinities between these? Like there's the set of counting numbers and there's the set of real numbers.
Mm-hmm.
Um, and it's not too hard to come up with a relationship between those two. Sorry, I think I'm missing something
No
in that
worries.
statement, but no, yeah, no worries about that. But like, can you find something that actually sits in the middle? And the answer to this question is known now, and it's known to be independent, so-called independent of the axioms of usual mathematics.
Mm-hmm.
So you can mathematically prove that it is possible, but you can also mathematically prove that there is a model in which there is no such middle infinity. And this like, and so when people talk about like applications, like what is real math, right?
Mm-hmm.
You can ask about like which one of these models is like better suited um, to discussing like things that actually exist. And there is like a philosophical debate around that.
Okay. So depending on what I was going to say, depending on the field of maths, infinity has different definitions. And
Uh,
then, but also, okay, it's again a wild claim, but then you can use a different definition of infinity to fit your narrative then. Is that, does that ever happen in maths? Or is it
um,
because the fields are so different that it doesn't really clash?
yeah, that's a good question. Um,
it's okay if I'm going off a complete tangent. Apologies.
No, it's fine. I mean, this is what we do on stream. Like I say, like the purposes of stream are to answer viewer questions and to get distracted. Um,
I'm
so
good at
I'm
that. Yes, pro
I
streamer.
so I've heard. Um, no, but yeah, I would say I think so. I think you could say it. I don't that you can sort of pick and choose your definition, like depending on what goals you're trying to achieve. Usually, it's not so nefarious that I would
Mm.
use words like shape the narrative. But
Yeah, it's very like it sounds almost anti-scientific, you know.
right,
But yeah, it's just a thought. This is a super interesting tangent. Jimmy does say there was a question. Just to go over the difference of combination and permutation. You mentioned these words. If you would you be able
yeah,
to explain the difference? Again, I wouldn't know exactly myself either.
for sure. And this actually gets to some of the work that I'm doing, like part of the uh part of the notion of using symmetry.
Hmm.
So so yeah, how exactly does this go? Uh, when so the slogan is that for permutations the order matters, and for combinations the order doesn't matter. So um, what that means is that like formally what a permutation is you have a big box of n things. You can tell the difference between the n things. So usually we say like the numbers between 1 and n. But you could think about them as being like balls of different colors. And you pull them out and you line them up. You pull out like 3 or 4 of them, or however many you want to pull out, and you line them up in a row. That's a permutation.
Okay.
A combination is you still have the same setup, but instead of putting them in a row, you put them into a new bag.
Okay. So there is no
So now
order
you
to
can't
them.
tell. Yeah, exactly.
Okay. Okay. That's really interesting. That's a really good. I should write this down. I'm going to bookmark this little clip moment. That's a really good explanation. I like it.
Yeah, well, I'm glad. um, so when I talk about like where's the symmetry here? Um, so the relationship between permutations and combinations can be thought about as like this rearrangement can be thought about as being a sort of abstract notion of symmetry. Like you could even imagine like very concrete notions where you say like you have 6 things lined up and you split them down the middle and you flip
Hmm.
them over, right?
Okay.
Um, so the fancy word that we use is that a combination is a permutation, except you've quotiented out, right? Like
Hmm.
division, kind of quotienting out the symmetry of permutation, right? Of swapping.
Oh, hello.
Oh, hello, am I
Okay,
here?
sorry. No, I thought you were still saying, but talking, but I didn't catch
Sorry.
it. Apologies.
Yeah,
Okay. Thank you for the explanation of the difference between them.
for
We
sure,
got
for sure.
sidetracked
Thanks for the
again.
question. Recursive tangents, yes.
Yes, yes. We had like a whole plan. Oh, I had a question in my head before I got distracted.
Okay.
And I know this is very probably basic, and I apologize if anyone in the chat already seems, you know, on the bandwagon and I'm not. You talk about symmetry, okay?
Talk.
When we talk about symmetry, if you could explain that to okay, symmetrical, i.e., what's on one side is the same as on the other. Are you talking about mathematically? Are they in maths when you talk about symmetry? When you talk about numbers, what does that mean exactly?
Yeah.
I know that
Um,
might seem very basic and obvious to you, and I apologize if
no,
it is.
it's not.
Okay.
There, because I think mathematicians can forget sometimes what the word symmetry actually means. Um, because like what is it supposed to be? Like it's supposed to be some like a geometric symmetry is you take a shape and you
Can fold it.
sorry, one more time.
That it's a shape that you can fold. Yes.
Uh right, yeah, that would be like a reflection type of
Oh,
right.
okay. That's not exactly symmetry. Okay.
You can also have like rotational symmetry,
Oh
right?
yeah, yeah.
Um, yeah, and it turns out that in we live in a world of 3 dimensions, and we think often in 2 dimensions. And in these settings, these are essentially the only kinds of geometric symmetries. Um, but when you expand your world a little bit, even going up just to dimension 4, there start to be these other things that are not quite reflections. They're not quite rotations, although they look a little more like rotation than reflection, I would say. Um, and um, and then things just like only explode. They get crazier as you go into higher and higher dimension.
Mm.
And the reason why you should care at all about things that are going on in higher dimension is because really, mathematically, to talk about higher dimension, you're really just talking about a longer list, right? So you're familiar with this idea, right? A point in space can be described by 3 numbers
Yeah.
plus a choice of origin, right? And so if you want to talk about 4 dimensions, just add a 4th number, right?
Okay.
I can't visualize it.
Oh, so
Most
mathematically
people
it
can't
might be
visualize it.
easier than physically to
Oh yes,
conceptualize dimensions.
absolutely. Yeah.
Okay, okay. Interesting. So what so to you 4 dimensions. So from a physics perspective we talk about time and space time and things like that. So from your perspective it's just for A B C
Yeah.
D or Z Y X Z, what goes after Z?
W
Yeah.
somehow.
Is it W? Does it go to W afterwards?
Yeah, that's if you need a 4th one, this is the mathematician's alphabet has some quirks, and one of them is that
Okay.
W comes after Z.
Interesting. I didn't know. Today I learned. Today I learned. Okay, so mathematically, that's what 4 dimensions is, and then there's symmetry. There is symmetry involved in the numbers.
Yeah, so right, the original question was
Sorry,
about
sidetracked.
was about the numbers. Yeah, so the sorts of symmetry that exist in the numbers. Oh right, I always forget about this because I only like to think about linear symmetries, but there is also the notion of translation, right? You can move things to the right
Mm.
or to the left. Um, and I think that is like the most prominent number, or the most prominent symmetry in one dimension. You also
Hmm.
have the reflection symmetry, but somehow the translations um, are sort of more uh, they're more present, right? There feels like there's a lot more of them. Um, and I mean, there are certainly very deep symmetries that you can talk about. Geometrically, though, like that's the game. You've got your translations and you've got your reflections
Hmm.
in in that one dimensional space.
Okay. So mostly mathematicians when they talk about symmetry, they're talking about geometric symmetry, the same way we visualize like us common folk.
Yeah. So this gets a little bit subtle. So the um when I say symmetries, I'm talking about like if you seen way too much math, I'm talking about these things called like group representation. So for mathematicians, there's this sort of abstract notion of symmetry, which is called a group. And a group sort of lives in this like way off like group land. It's like not doing anything. And a representation is a way to like actually make it useful.
Okay.
um, so the representations in particular have a geometric. And so when I talk about these geometric symmetries, I'm saying like, okay, come out here from like your pie in the sky and like actually do something for me, right?
Okay.
Yeah,
Okay, this is, I suppose, where I would struggle. I can't visualize the mathematics that you're talking about of the symmetry. It's so geometrically, I can kind of understand it a little bit, but this is where I guess to me, maths is like crazy to me. The level of mathematics that's involved.
yeah.
It,
I mean, some good questions have been asked,
yeah.
right? Which means that you start to get to the craziness sooner. Uh, but yeah.
Are you seeing the questions that are posted at the moment?
Oh no, sorry.
Oh,
I
okay,
just the
good.
questions you've asked me.
Oh, okay, okay. There's because they're getting crazier now. There's
Oh no.
questions being asked that I don't even understand how to ask those questions. Um,
I do
uh,
see the chat, so if there are names you want to point me to, uh,
see the 4 dimensional space video games coming out. Okay, so If we can log those as official interviewee questions, guys, I can ask these questions towards the end of the stream. If that makes sense. If you guys want to log them, there's a channel points redeem. Everyone should be able to ask at least 5 questions, even if they've never watched the stream before. That way you can keep track. Also, thanks for the follows, subs, and bits. I'm so sorry I turned off the sound alerts because we don't want to get too distracted. Because we get distracted very easily. Well, speaking for myself.
Oh, speak for both of us.
But yeah, so you were talking a little bit about higher dimensions, which was really interesting. And that's got to do a little bit with your research, did it? Or
Yeah, very much. Um,
and did you conclude
yeah.
anything in your PhD research? Whoops.
Did I conclude anything?
Mm.
Yes, I did. I don't know. I don't know how much. Um, is there anything that I can sort of say quickly?
Yes. Oh, not even quickly. Maybe like a lower level. You know.
Yeah. So one of the tricky things about combinatorics, like one of the very beautiful things, is that a lot of the constructions are elementary. So elementary is the word that mathematicians use to mean like you don't have to like go to school for a long like it's
Aw, I
with
thought
a
it
high
was
school
something
education.
Sherlock Holmes said. Damn it. Now you're
With
ruining
like
a
a
perfectly nice word for me again, Stucky. God damn it.
Um, yeah, so I made this distinction when I was like in the general audience portion of my PhD defense. I said, the things we're going to be talking about for a while are going to be elementary. Like you don't need any like fancy math
Background.
background to
Mm-hmm.
understand them, but they're not simple, right? There's some moving parts that are going on, and keeping them all in your head is not so easy. Um, so. Um, Yeah, so for instance, like I um one thing that I did in my dissertation was I showed that there's a certain polynomial, right? So like 1 plus x plus 3x squared minus 4x cubed, right? Stop at
Mm-hmm.
some point, but something
Mm-hmm.
like that. Um that that um if you plug in these very special complex numbers called roots of unity, then you end up getting out whole numbers. And not only whole numbers, but these whole numbers actually count something, right? So for me, that's the interesting bit is that, I can just shove random numbers into a random polynomial, who cares? But if you make this special choice for the special choice of polynomials, then you actually like understand something, uh, uh, some answer to a meaningful counting problem. Um, and that part, like that much I can say, right? But like what are these polynomials? Well, this gets very thorny. uh, and like they have some relationship in particular to the counting problem. Somehow they're you start with like a normal counting problem, and then you produce this polynomial. You can also take the problem and you can quotient out by some symmetry. Um, and plugging in these special numbers turns out to give you the answer to the quotient problem.
Okay.
Um, so yeah, so that's perhaps what I can say. There's this. I was not the first person to come up with results like this. Um, so the theory had been built
Existed.
essentially by my advisor and some of his collaborators.
Mm-hmm.
Um, but yeah, there was this new context in which I discovered that was possible.
Jimmy asked this, but I think it'll be a good question across the board to ask. So, from a real world application, what can you this stuff that you're doing, these counting numbers, this higher dimensional counting numbers that you're talking about, what use is there? I know that sounds kind of like almost mean.
No, it's a fair question, and to give the fair answer, I have no idea. I I can say some things. The um so the algebra part of what I did, which is like sort of a aside from what I just talked about,
Mm-hmm.
um, but is related to a field called algebraic geometry, which is sort of similarly, you put the words together. You use symmetry to understand geometry problems. Um, and there's a really exciting program in geometry in algebraic geometry right now, um, to use it to understand like for computer vision, um, for um, and I'm trying to think about like where this connection comes in, because like I said, I don't really know. Like
Mm.
I'm sort of saying words that have been said to me more than things that I actually understand.
Hmm.
Um,
Suppose in the long run that there's no, maybe there's nothing too fruitful just yet, in the sense that you directly don't work with the work, like your work is a lot more theoretical based and you might not have hands-on experience or knowledge of what exactly, how directly these will be used, but I'm guessing in some form of computer programming.
yeah, I mean I mean, the AI revolution is upon us, and um, and it's certainly true that a lot of people who think about combinatorics are coming at it from a computer science perspective.
Mm.
And there's a lot of interest in trying to use these ideas um, to essentially make computations feasible.
Mm.
Um, because one of the big problems I the big computational problems in combinatorics is that you usually have to do things like, oh, here's some procedure. You apply that procedure to every subset. Okay, well, there are a lot of subsets, it turns out. And if you're just doing this naively, you can't reasonably
The computer can't
check
solve that
all
for
of them,
long. Oh, okay,
right?
yeah, yeah. It'll take too much for the computer program to run, and etc.
Right. And so you're hoping to use the algebra, to use the symmetry of this counting procedure to make the problem smaller, right?
Mm.
To do
Makes
something
sense.
that's actually feasible. Yeah.
Mm. That makes a lot of sense. You did mention it there just a little bit briefly, and I want to kind of dabble into this a little bit. If you have an opinion on this, because I have none, I'm very, very uneducated in this area. But AI in mathematics,
Mhm.
do you know of anything that's happening revolutionary wise? Do you have any opinion? The answer could be simply no. But is there anything interesting happening with AI in mathematics at the moment, or the use of AI in maths?
Yeah, so my primary feelings about AI are not mathematical.
Okay.
I I'm really dismayed by just like the rampant art theft that's happening right now. And like I won't go on too big of a tirade about this, but um there on the actual math side of things, um there was a really interesting talk that was given at this year's joint meetings, which is the big math conference that happens in January, um, by one of the famous people in the field named Terry Tao. And um, Tao and a couple collaborators recently proved some big theorem. Doesn't really matter for our purposes what it is. The reason why he was talking about it was because he got very excited late last year about formalizing this proof using a programming language called Lean. Essentially, it's just a way to make the computer actually understand the math, right? And so it can check a proof as opposed to
Okay.
just doing the computation.
Okay.
And so what he expressed in this talk is some hope that some large language model type technology could be plugged in um, to like these automated theorem provers. So because as if you've spent any time with ChatGPT, what you know is that it's very good at coming up with lots of ideas very quickly. Now, a lot of those ideas are garbage, right? But it can do it very fast. So if you can somehow integrate these two tools and use ChatGPT to come up with a bunch of really garbage ideas, check them using the proof verifier, and have that tell GPT like, "Hey, this idea was kind of good actually. Like, keep thinking about that." Then maybe you
Oh.
could start pushing in the direction of automated theorem proving, which is sort of the ultimate goal, right, of AI intersect math.
Really? Oh, wow. That's so crazy the way the loop works. Interesting.
Yeah, it's very theoretical at this point, but I think he made a good case that like we're at the beginning of the age where that might be possible.
Mm. Machine learning in a way, yeah, that sounds really cool. So you have two programs, ChatGPT and your theorem proving, and they just loop around each other constantly, one confirming while the other is expanding over and over
Right.
again. That's really cool. I mean, it's so great to hear something positive about AI because, again, like I'm sure we both know that there's a lot of negative stuff about it as well in the media and well, not even just in media, in artwork and everything that's happening in the world.
Yeah.
I learned something today.
That's
there's
good.
there's a few fun questions that were asked a while
Oh,
back. So Phobos had asked, "Do you have a favorite symmetry?" I don't even know if that is that a real maths question?
sure.
There is.
Yeah, I'm gonna maybe cheat a little bit and interpret that as I mean my favorite type of symmetry is reflections, right?
Okay.
I spent I spent 6 years thinking very hard about reflections. So if they're not my favorite at this point, something went seriously wrong. Um, but maybe to cheat slightly, the I'm gonna interpret that as being like my favorite like group of symmetries.
Mm-hmm.
And I mean, it's hard not to like S. It's so the symmetries of a triangle. Um, the if I was like trying to be impressive, maybe I would say something like S6, which is the symmetries of a five-dimensional triangle. Because like it has some like extremely weird properties. Like all of
What is
these
it called
groups.
again? Sorry to distract you.
What?
What's that triangle called again?
Oh, I just called it a five-dimensional triangle. Would it have is there like a standard name
I
for
thought.
five-dimensional things?
Oh.
Um,
Polytype? 5 cell? Okay. Sorry, I just wanted to look what it
yeah.
looked like. I got distracted. Keep going. Apologies.
No, no, you're good. Um, yeah, but like, I mean, honestly, S is I like S.
So that's your favorite. Okay. And I suppose leading on while we're on the band, please explain five-dimensional triangles, Jimmy asks.
Yeah.
I suppose four dimensions we can kind of. Oh, sorry. Is your perception of four dimensions different to my perception?
I don't think about it. Well, I don't think about it like as time, but I think
Yeah.
we talked about that. So I think we're sort
Okay.
of on the same page here.
So you just think of it as another number, basically. Do you visualize higher dimensions? No.
Nope.
Can
Nope. I
anyone?
have no picture. I think there are some people, like some folks who do low-dimensional topology, low-dimensional geometry,
Okay.
and low dimension includes 4 dimensions. um, that
Until you get to the
do
11th, right? It's 11 is a secret
exactly.
number, isn't it?
Actually, what is actually kind of stunning is that the secret number, as in for the sort of problems that we know how to ask right now, seems to be 4. Um, that there's a really big difference between things that happen in 4 dimensions and things that happen in 5 dimensions and higher.
Okay.
And this is a phenomenon that is really not very well understood. But
Cool.
for instance, like one very concrete way of saying this is that, so the even if the name is not familiar, most people are probably familiar with the Platonic solids, which are like the regular three-dimensional shapes. There's the triangular pyramid, there's the cube, there's the octahedron, right? So if you play D&D, these are all of the dice shapes, right? These two ones, the D20 and the D12.
Yes, explain
Um,
this in D&D terms. Let's go.
exactly. So there's only finitely many of these.
Mm-hmm.
There's exactly 5. Um, in 2 dimensions, there's infinitely many. You can pick, there's octagons, nonagons, decagons, right? Okay.
Mm-hmm.
Um, in 4 dimensions, there's all of the analogs of the three-dimensional things carry
Mm-hmm.
over, and there's also another one. It's not. It's just like a thing that happens in 4 dimensions.
Okay.
Um, and so you've got 6 of them. But then it turns out that starting in 5 dimensions and forever after, there's only 3. It's only the high-dimensional analogs of the triangle, the cube, and the octahedron, and that's it. So
Okay.
somehow things like collapse geometrically when you hit dimension 5. Um,
Wow.
yeah.
Does it get
This
worse
is
with 6, 7, and 8?
what's up?
Does it get worse? As in, does it become less with 7, 8, 9 dimensions? Does it get worse, or there's no?
Nope. You get those three families forever and nothing else.
Oh, interesting.
Yeah. It's very mysterious. We really don't understand like what
What?
is happening at that barrier.
That's really
Um,
cool.
I mean, for
Okay.
this problem we can understand, but like there are many problems for which this seems to happen, and we
It
don't
almost
understand
seems
that happening.
counterintuitive to me. I would have thought
Very
that in
counterintuitive.
higher dimensions there would be more. Do you know, like you've more parameters to play with?
Mhm.
I would take a wild mathematical statement and say there's more combinations. You would think so. I would have thought
Yeah,
so. But see, that's a really cool thing that you said there. That's really interesting, and I understood it. I think
nice.
feels proud.
You've understood a lot of what I've talked about. I feel like you it's almost unremarkable at this point.
Fizzy had asked opinions on simple cubic structures. So you were talking about triangle ones,
Mhm.
triangular ones, on simple cubic structures. They make up almost everything. Is that true?
You can interpret things that way for sure.
Okay.
Um, there's there is something genuinely mathematically nice about 90-degree angles. Like it's yes, like in 2 dimensions the Pythagorean theorem exists, right?
Mm-hmm.
Um, and essentially because the Pythagorean theorem exists, like 90-degree angles continue to be awesome as you go up in dimensions. So cubes play into that very naturally.
Okay.
Um, yeah, there's also some very interesting things that you can say about cubical complexes from like a geometric perspective. Like if you think about like the shortest distance between like in 2 points in an
Mm-hmm.
arrangement of cubes, um these things form so-called cat zero space, and that just means that like triangles are skinny. Like
Cat
it's
zero space, like
cat
cats.
zero. Yeah, like cats. um yeah, yeah, cubical complexes are awesome. I spend more time thinking about the simplicial side of things, but which is the triangle stuff.
Mm.
Um,
Is that your favorite
because like
shape? Triangle.
yeah,
I think structurally triangles are the strongest shape as well. Isn't that true?
I've heard this.
I've heard this,
Um,
but I don't know if there's any truth to it.
I 100% believe there's truth to it. I just don't know what it
Mm.
means. Right? Like uh, that's the other half of the.
Another question by Aiden was asked: favorite prime number? Do you do much work with prime numbers? Do you have a favorite prime number, and why? There was an addition to that question.
Yeah. So I my instant answer to this question is 57. And if you think
57.
for just a second, 57 is not a prime number. Um, it's a
No,
3 times 19.
no.
Um, but there's a very famous story.
57. No.
57 is the so-called Grothendieck prime because
Oh, because 3 is divided.
yeah, I mean
This is
it,
like when I found out 51 isn't a prime number. This is trauma.
yeah.
Okay, sorry. Okay.
Mine was 119. I was very disappointed to discover that 119 is not prime.
What
Um,
is 119?
it's 17 times 7.
Oh,
Yeah,
fuck. Oh,
70 plus
jeez.
49. Yeah.
Okay.
But
Sorry,
yeah,
we're
the
distracted.
the story behind 57 is so there's this guy named Grothendieck. He did a whole bunch of like very pioneering work in number theory. And of course, number theorists care a lot about primes. Um,
Mm.
but he was very much on like the abstract side of things. And so at some point he was talking to a contemporary, and they were like, I don't understand what you're talking about. Like, can we make this more concrete? And so he's like, okay. So he makes it a little more concrete, and the guy's like, I still don't understand what you're talking about. Like, can we take an actual prime number? And Gardnik is like, you want like a number? And he's like, yeah. And he's like, okay, let P be 57. um, and so it's this
Anecdote amongst mathematicians.
right, it's this sort of joke about like, you get a little bit lost in the sauce sometimes. Right?
Okay, I'm glad that your answer to your favorite prime number is not an actual prime number. That's brilliant. On the topic of prime numbers, I did watch your Veritasium video a couple of months ago. I don't know if you watch Veritasium.
Sometimes,
Yeah,
yeah.
there's a good few. Sometimes he has great videos, and one of the videos was about like finding the next prime number and why that's so
Ah, yes.
important. Do you know why? Would you be able to explain to me why finding the next prime number is so important?
I was just talking with someone about this in the community.
Oh,
And my conclusion was like, no, I don't. So if somebody has like a better answer than what I'm about to give, feel free to post that in the chat. Um, but from what I understand, the um the benefit of finding like these gargantuanly large primes is to
mm-hmm,
develop tools to find primes that are slightly smaller.
mm-hmm,
And the reason why you want primes that are the reason why you want a lot of primes in a certain range is for cryptographic reasons.
mm.
Um, so essentially, there are cryptography algorithms that so for like encoding your data and making sure that you can send information securely online that um, that that use the difficulty of certain problems, and those problems get harder based on a fixed prime number that you pick at the beginning and how large the prime number is. Now, you never want to use the largest prime number because there's only one of them, right? And
Okay.
so you don't want to use that one, but you want to have a number that's sort of as large as possible, but for which there's like plausible deniability, right? There's a bunch of other primes sort of swimming around in that
Oh,
scale, so it's hard for an attacker to be able to figure out what your secret prime is.
that's that's wow. Okay. Yeah, I don't think I understand enough about cryptography to really, and I think there's something. Anyways, my rant would be on the topic that they're geniuses in their own right and in their own field, and it's something that I'll never
Definitely.
understand. But yeah, I'm glad that we got sidetracked a little bit about prime numbers. But I'll just go back on a question that was a bit more involved.
Okay.
So a question: with your work and approach to your research, do you consider yourself more on the theorem problem solver side, like Eridus, or a theory builder, like Grothendieck? And if so, why? Um,
Um,
so I don't understand anything that was just asked, but I'm the messenger, so don't shoot me. What does that mean? I don't know those
yes.
names.
So Grotendieck is Grotendieck.
Okay.
Uh, the Yeah, while I try to figure this out, I'll talk very briefly about Erdős because he's a very interesting character.
Okay.
So he was a combinatorialist, and I think of him as most active from like the 50s to the 70s, like that time.
Okay.
And he was homeless. He would literally he would show up on your doorstep as a math professor, and he would say like, "Hey, you want to write some papers?" And he would get housing from folks in the community, and of course he would say yes because Erdős wrote papers. There were, I think he's got, I mean, it's multiple hundred. I don't know if it's in the 400 or the 700 range, but it's tremendously prolific. So
Wow.
these are the two people involved. Um,
I
I
need.
think that I'm a
Sorry, I was going to make a joke about needing help writing my paper, but anyways, go on. Sorry.
yeah, relevant XKCD, bringing Paul Erdős back from the dead. um, I would say that I'm closer to the problem solving side. I think that anybody who gets into pure math has an attraction to these like beautiful theories, and I like them as much as the next mathematician. But when I think about like the research that engages me most, it's often like in service of a concrete mathematical goal. Um,
Okay. Hopefully, Setter's still there when we asked the question. I was just going back a little bit, and just again, last question that I'm going back on, and I'll keep
sure.
up to date with everything. Is that have you seen any of the fourth dimensional or non Euclidean space video games coming out?
I haven't.
Okay.
Again, a relevant XACD from a long time ago was an advertisement for Mega Cure. And that game was in development for so long that I think still is in development. that I mean, I'm very interested. I'm really excited to see what happens with it. But I'm sure that other people in the meantime have made some games um that explore the fourth dimension, that explore four-dimensional thinking and also this like non-Euclidean. Those are like two different ways that you can sort of
Mm,
break your brain
mm.
geometrically. Uh, um, and I've seen some cool like hyperbolic, so non-Euclidean visualizations. I don't think I've seen any of the games that are related to them
Okay.
yet.
Yeah, something to keep an eye
Uh,
out for.
if you have recommend, oh, Manifold Garden, I see in the chat.
And 4D
Um,
golf.
4D golf. Okay. Ooh,
That's interesting.
that sounds fun.
Is that like 4D chess? Oh no, that's 3D chess. Oh, is it 4D chess? No, 3D chess. Sheldon made that
Um,
up back in Big Bang Theory.
oh, I see. I see.
So we're jumping a little bit back, but I love some of these basic questions that are being asked because I would love to know your
Yeah.
inside thought process and if you could explain it again from to a general public. So Facey, for example, asked, "Could you explain I in the most simple way?" So I'd love to hear this because I'm sure you know in quantum we use I all the time. It's literally the backbone of every wave equation, everything like. So I'd love to understand it a little bit more if you can provide more insight.
Yeah, so
If you
I'm
can.
going to take this opportunity to soapbox a little bit.
Okay.
Um, um, a philosophical question that I think is mathematically very uninteresting is the question of like, what are numbers, right? So why do I think that's mathematically uninteresting? Because for the modern perspective on mathematics is that like what the objects are that you're manipulating don't actually matter. What's interesting about the objects is the relationships that they have to each other, right?
Okay.
So two, like I don't care what two is. I care that two is one plus one. Um, right? I don't care what pi is. I care that it's a number between three and right?
Okay.
And so that's the way that I'm going to phrase the answer to this question. Like, I like the question like, can I explain I? Like, no, it's some object, right, that exists out there, but it has some interesting relationships to other numbers that are more
Okay.
familiar. And I think that's certainly like the mathematical perspective on a question like this. Um, so there's two distinct ways to think about the complex numbers about I. And sort of the miracle is that they turn out to describe the same objects. So one way is um, is just like a desire for solution. If you plot the graph of a parabola,
Yeah.
um, it sometimes it has the usual case I guess is that it has two solutions. It
Mm-hmm.
hits any horizontal line, except unless that horizontal line goes straight through the bottom point, in which case there's only one solution, or it's beneath the figure entirely. And so you could ask like, hey, like, is there some way that we could like make sense of this anyway? Um, like, and you could say like, no, these two things do intersect in some, can you go to some higher dimension, for
Mm-hmm.
instance, right, and try to understand that. And it turns out that sort of if you set things up carefully, yes, you can. And that's one way to think about the complex numbers, to think about I. The other way is that you can think about rotation, right? So it maybe not surprising that I'm phrasing things in terms of symmetries, um, but um, but when you multiply by a number like two, what that does is that it scales your number line, right? The the distance after you multiply by two, the distance between 5 and 6 used to be 1, now it's 2,
Mm-hmm.
right? Um, so um, there are tools like matrices for handling like rotations in 2 dimensions, but could you like invent a number system that is powerful enough to sort of understand rotations as well as scaling?
Mm-hmm.
And it turns out that the complex numbers are such a thing. So in that setting, I corresponds to a rotation by 90. Um, And yeah, and so like I said, these two things like don't feel related to each other, but sort of the miracle is that they are.
Okay.
They're precisely the same object.
Okay, so it's mostly got to do with the relationship. You, if you were to choose to explain, it's based on relationship rather than what it is.
Right. Yeah. Yeah.
Perfect. Thank you so much for the question. And then a more kind of out. We're kind of jumping out a little bit, but just a personal question: how did you get into maths and maths research?
Yeah, so shout out to the University of Washington. There was a program. Uh, the story, this story is so like it's such like a series of accidents kind of thing. Um,
Series of
I
unfortunate
was
events.
exactly. Uh, I was the way that I like to start this story is I was really into World of Warcraft when I was in middle school. Um,
Yay! Okay, we can all
and because I
relate.
was, of course, right? It was the thing to do. Um, and I got really into podcasts because there was a World of Warcraft podcast, and I just like needed more World of Warcraft content, and that was like my first introduction to podcasts, and I was like, okay. Um, and so when I was at the University of Washington over the summer, I for because I have family who lives near there. Um, I saw an advertisement for a podcasting class, and I was like, Mom, I want to go to this podcasting class. And she was like, Yeah, whatever. Like, so so the next year comes around, and she's like, and I'm like, Hey, Mom, I still want to go to that podcasting class. And she's like, Really? I mean, like, but she was very nice about it, right? But of course, it was just some random flyer. So she like it probably wasn't even happening at that point. But she did find this like math camp. And she was like, "This is kind of like podcasting," and I was like, "Not really," but I applied, and I was very fortunate to get in, and that really changed my life. Like it really, my experience there was one where I saw math that I'd never seen before. It like a different a different philosophy of doing math than I've ever seen before. I very much had the experience of like classroom stuff and also like contest stuff where like there's like tricks that you need to know, and that will get you to a solution as fast as possible, right? Um, and and what I saw at Simu was very much the kind of math that I actually appreciate, which is very much not this. A place where there is um, room for asking questions, a place where there is room for messing around, right? Just kind of enjoying yourself
Mm.
inside of this like other world. And so I sort of fell into to things from there. Another part of that experience that has really followed me throughout my entire life is it was a very communal learning experience. They made the homework sets really hard, and they encouraged us really strongly to work with each other. And essentially, you had to work with other people, or you would didn't have any hope of getting these things. Um, and yeah, so we learned, we learned what it was to develop like professional relationships, to talk in ways that were convincing to each other. So I learned a little bit about like what it meant to be part of a mathematical community from that experience, and that was something that I was tremendously attracted to. Um,
And now you're here
part
today.
part of why I'm still streaming on Twitch is because there's this whole it's sort of budding community of math streamers who are um, who have been fantastic people to play around with.
I'm glad you found a community. I think Twitch is a really great way to find a community. I know that STEM streamers are on the smaller side on Twitch. I don't think that's too bold of a claim to say. But I really appreciate the stuff that you do and the work that you do, which is really cool. And yeah, Aiden does say, I mean, Twitch is kind of like a podcast. So, I mean,
Exactly, we got there.
we what started off as one thing, it ended up going full circle for you in the end.
Mhm.
Actually,
Yeah.
just to ask a bit of self promotion, of course, but also like, what exactly, how much, what kind of stuff do you cover on Twitch when you do talk about maths? Do you would you be covering very basic mathematic things, or is it more complex based, like only for mathematicians kind of level? What kind of stuff do you talk on your Twitch?
So one thing that almost every stream that I do is open for viewer questions. So we, if your question is like not too like notationally involved, and you can type it in the chat, then that's great. If you do want to do some like more dense stuff, then we have a Discord that you can post that too.
Mm.
And so I love to get the questions from the folks who are listening. I like to help people. Like I can talk about random math, but I would rather that at least one person gets some value from it, right?
Okay, I
Um,
like that.
when the stream is small enough that we don't have viewer questions to take up the entire time. So on our off time, I always try to have some sort of activity. Um, so one big project I've been trying to learn Lean, this programming thing. Um, I have I'm I've been working on some I've done some like paper writing on stream. So
Okay,
that gives me an opportunity to like get some stuff done, and also take breaks to sort of just explain some things, some basics from the work that I actually do.
that's
Um
fantastic.
yeah,
I'm going to come into your stream now. I'm going to talk about infinity with you.
perfect.
We're
Please
gonna
do.
bring it up infinity. So if anyone of my community doesn't know you guys, you can give a follow through to Stucky through in the title. It'll cover all the socials. So if you do have a math question, uh, Stucky promised here live on Twitch that they'll answer it for you. So
Oh, I didn't say that. I always say this. I say I can't guarantee I'll answer your question, but I can guarantee I'll think about it. Right?
that's a good. That's a very professor answer. Are you thinking
Um,
about professoring? Sorry,
uh,
did you want to say something?
yeah. Before I answer that, I do want to say, like, if you really want to talk about Infinity, though, like, I'm happy to talk about it. But there are a couple people I want to shout out real quick. Um, so very much on the analyst side of things, Zach over at e to the 2 I pi, the two is a number, but everything else is letters. Um, is It does a lot of analysis related content. And then we also have sort of a resident philosopher in the community over on Danny Highway. And Danny is always all too eager to dive into philosophical topics. Much love to you, Danny. um, and so you you certainly if you start talking about infinity with him, I think you'll get some interesting conversation.
Nice, nice.
But yeah, the professorship
Oh
question.
yeah, are
Um,
you planning on being a lecturer, or like if this is too personal, you are more than welcome to be blunt and rude with me and shut me up. But I'm just personally interested in asking you, like you're clearly a very well educated person, very well spoken.
Thank you.
So do you have any interests like that?
Yeah, so I'm sort of coming down from an academic career. Um, I I have I have some sort of feelers out there, but it's I think that a lot of my research interests can be a little bit flighty, and so from that perspective, like I would be thinking about more of a like an undergrad focused or a teaching focused institution, um, and there I'd do it if I could. There's lots of questions. There's lots of things that go into a professional career. I'm being a little diplomatic right now. Like, we could probably sit here and shit talk academia for a while, but
Oh yeah,
um,
oh yeah. That's my field of
shall we say?
expertise.
Um, but yeah,
So
um,
academia kind of broke your heart a little bit.
a
University
little bit.
structure, yeah. So,
Yeah,
why is it that every guest we've had has spoken about this? This is so heartbreaking. We had Homozygote here as well, and
yeah.
he also spoke about that. And Skylibs literally was talking about how she's not too keen on a PhD because of this, and obviously myself as well. That Academia can really break a scientist's heart when you realize what goes on behind
What's
closed
involved?
doors. I'm so sorry to hear that. But you're still passionate about teaching, so it could be kind of in the similar boat as me, as where teaching in a place where you don't need to do postdoctoral research, where you're just a lecturer in an IT or a community college kind of thing. Is that something that you'd be interested in?
Yeah. First of all, just yes. I also think that um, academia has a way of convincing you that it's the only place where you can do the things that it lets you do.
Yeah.
But um, but of course there is research that is happening in industry, as well as in government, actually, sort of for math more seriously in government. Um,
Oh no,
but
please don't go to the weapons division. No, come back to
uh,
us. Come
the
back.
NSA is the largest non-academic employer of mathematicians. Um,
Wow.
yep. Uh,
In the world
maybe
or
math PhD. Uh, I think in the world, certainly in the US. I think globally.
damn.
Yeah. Um, and then also from teaching, like there's so much opportunity for the kind of like human interactions that are the best part of teaching that happen
Mhm.
outside of the classroom environment. Whether that's something like what you do, right, with science communication, or even just inside of sort of an industry job, right? There's always training that needs to be done, and you can very easily find yourself in a position like that if you're looking for it.
Mm.
Um, so I don't think that I am so actively looking for for like teaching, because I think that like that's gonna come, right? Um, and I there are other things that I could focus on for like finding a place where I'll be happy.
I hope you find something because you clearly deserve it, and you're a sweetheart and a half as well. So it's just so heartbreaking to hear so many very intellectual people, very smart and very kind people on the show. Just alone on Tofu Tech Talk, I think pretty much everyone that had the opportunity to go into academia has literally had their heart stomped on and refused to continue it forward. It's just makes me angry. I can sit and rant here for another hour or two about that. Probably will after this stuff I take time. It's the thing that I do best, which is rant and shit talk. And yeah, the weaponizing. Jimmy is joking, like, how would you weaponize symmetry? But like, Skylibs was one of our guests.
Mm,
Was she the last guest we had? I don't
I think so.
remember. But she was looking for jobs all around Scotland, and everything is military based. And
Mhm.
she did space trajectory stuff. You would think it would be like space exploration kind of projects. No, it's all missile trajectory, missile launching, missile work.
Yeah,
And that this is Scotland. I'm going to take a wild guess in the US is even worse.
probably. Yeah.
Just a little bit, just a little bit. And is it true that your research in the US is all from the weapons, not weapons, what's it called? Military funding. Is that how a lot of postdoctoral research works in biology, chemistry, and physics?
Yeah, for sure.
Really? Is it
I
maths as well?
So math gets a little bit tricky. A lot of funding comes from the NSF, which the National Science Foundation, which is ostensibly not related to military or defense. But a lot of money comes from the NSA as well. Outward. Like a lot of the grant funding is what I'm
Yeah,
talking about.
Grant.
Um,
Yeah.
yeah, yeah. So I think it's a little bit less pressure, at least inside of academia, a little bit less pressure than you would experience from a lot of the hard sciences, for instance.
Mm.
Um, but there is always the NSA for job
Oh,
prospects for
don't
the
say
folks,
it's Stooky,
right? So
no.
so there's
Ah.
there's pressure in that sense, right?
Mm. All right. If you weren't mathematician, if there was like a small trajectory in you, would you have done physics? Would you have joined the dark side? Were you anywhere close to ever doing physics in your life?
Um, Not seriously. It was before I went to this program at the University of Washington. like physics was what I enjoyed most in my high school classes. Um, but it was really I really just liked the math, and I didn't realize that yet. um, yeah, if I wasn't a mathematician, I'd probably be a linguist, honestly. Um,
Whoa, really?
yeah, and if you tune into the stream a couple of times, I have this very at a distance armchair fascination with linguistics. Um, and it was my concentration in college, which was very funny because I never took intro ling, but but
Okay.
I still got enough for like this. It's not quite a minor, but something like that.
It seems
Um,
like it's a popular thing. I know a lot of physicists also have linguistics as their thing, like their little. So they will go on rants. Basically, you'll say something physics wise, and they'll be like, "Did you know the origin of the word?" And they'll just go off on
yeah.
a tangent. Like it's a popular thing. It seems to be. That's really interesting that you say that. Um, Thank you so much for sharing that. Really, really appreciate that. Do you have anything that else that you'd like to share or talk about? Um, is there any last minute declarations that you'd like to share?
Oh, is this a last minute declarations
Yeah,
question?
yeah, last minute.
um. Okay, so there's one mathematical thing, and then there's a long list of shoutouts. How much time do you have? But let me
Is there another story you'd like to share that I didn't touch?
uh yeah. Well, you did say we were going to talk about the aperiodic monotile. That wasn't the thing
Yes.
that I had in mind, but let me do that since we
Yeah,
did
please,
advertise
please,
it.
please do.
So we talked about translational symmetry, right? Um,
Could you explain
so
translation symmetry again, just in case anyone has never heard that before? What is translation symmetry?
for sure. Um, so translation as in like picking something up and moving. Um, and so what makes well, something like some, for instance, tiling of the plane, because that's what we're going to talk about. So some arrangement of shapes in the plane has a has translational symmetry if um, you can look at it and then turn your back. I can like shift it in some way. You turn back around and you can't tell that I did it. Right? That's what it means to have translation.
Okay.
Um, so there are ways there are some shapes that exist. I say as if they're very fancy, but like triangles and squares that can cover the plane without any gaps, without any overlaps.
Like a
So this
piece of
is
paper, like a
exactly
fill it up with triangles and squares.
exactly.
I'm on board.
Um, and and you can do that in a way that has translational stuff, right? The squares is the easiest, right? If you just draw grid paper, and if I like shift the grid up by one or two squares,
Hmm.
you can't tell that I did. Um, so this is a so-called periodic tiling of the plane. We say that squares have a squares can tile the plane periodic. Now, they can also tile the plane non-periodic, like in a way that I can't like do this procedure, because you could just like take one of the columns and you could like shift it up, right? And you could sort of jiggle things around, right? Um, and produce so that like no matter how I shift it, you could turn back around and say like, hey, you screwed around with the squares. Um,
Okay, okay.
but
Will it cover the whole piece of paper though in this figure of speech still?
right, so I'm taking advantage of infinity right now. So
Oh,
I'm
okay.
allowing myself to go off in all directions so that when I move it up a little bit, there's still more that we can pull back up to
Okay,
to
makes more
fill in the
sense.
gap.
Mm.
Yeah. Yeah, no, it's a good question. Uh, the the infiniteness is really important to the story.
It comes back
Um,
to bite you.
so uh, there a reasonable question is there are there any shapes, even any like collection of shapes, that you could tile the plane with, but no matter how I'm like clever enough to tile the plane, I could not produce a symmetric shifting, right? Or I cannot produce an uh, translationally symmetric tiling, right? Um, and it turns out the answer is yes. For some very esoteric reason, somebody realized that this was equivalent to to a question that was asked in 1900, and they said like, oh yeah, there's a way to do it. The number of different shapes that you need to do this is somewhere around like 30,000. You need 30,000 different shapes, but you can do it. um, and then people started thinking about it, and they said like, oh no, you can do it with 7,000. You can do it with, I think people got it down to a couple of hundred. And then Penrose in the 70s shocked the world because he created this tiling that used only 2 shapes.
Oh, I heard about
The
this.
And so you
Yes.
might have seen about this from like quasi-crystal stuff.
Okay.
It's very related to that. So, but of course, when you start with 70,000 and you've gone down to 2, there's only one question left, right? Can you do it with just a single shape?
One. Okay.
And this question was open until March of last year. And last year, a team of 4 people figured out, found a shape and proved that no matter how you use that shape to tile the plane, it does tile the plane, but no matter how you do it, um, you can sort of tell where you started, right? You can't.
Oh. What shape is that?
It's called it's called the hat.
The hat.
Um, yeah, and I will send.
Yeah, you can
See
send
it's
to me
even
in
still in my
Discord.
clipboard. Yeah, so I've just sent on Discord a uh the the usual tiling by the
Yes.
hat.
Oh, sorry, chat. I promise Stucky's still here. It's just me that has removed them. Apologies. I can show
uh,
everything on stream.
yeah, and I see in chat, Aiden is saying that you saw a video on that. Yeah, this was a really big deal. So there was a lot of people who talked about this when it happened. There was a quanta like their like biggest things that happened in math in 2023. It was one of those. Um, did I stall it for long enough?
That does not look like a hat.
It doesn't. Yeah, it doesn't really look like a hat. You could
What
kind of
world does
imagine
that
putting it
look
on your
like?
head.
I suppose maybe a cowboy hat. So wait, so you know exactly where it starts? Is that what you're saying? So by looking at this image, I know where it starts. Is that what you're saying to me?
Yeah, more like that's the way to say it without like describing how
Really
translational symmetry
mathematically.
works.
Mm.
Yeah, so what they proved is that every tiling by the hat is so-called hierarchical,
Mm-hmm.
which means that um you you can find if you like if you start with one piece, then there's sort of only a couple rules that you can use to build it into a larger piece and build it into a larger piece and build it into a larger
Mm.
um and those and every tiling like has this structure. So you can sort of figure out where you started in some sense because you can shift things or you can sort of do the process in reverse. Now,
Yeah.
that's not literally true, but more or less you can do
I
that
see
and
what you
so
mean.
come back to a small.
Mm. It's so fascinating. That shape is so banjaxed. Like how did they even come up with this shape? Do you know what I mean? That's not an actual shape. Well, I mean it is.
Right,
But you know
yeah.
what I mean? It's not like
I
a
know what you
thing.
mean.
So it's mad to think that they figured it out. Do you think there was some programming involved? Was it
Oh, for
computational
sure.
based? Oh, it was all computational based, yeah.
Yeah, a couple of the people in this project, Chaim Goodman Strauss, I think most notably, is an amateur mathematician. And so like has been thinking about tiling problems for a long time, like is
Oh
is
wow.
very more well versed in the field, of course, than I am.
Mm.
Um, but um, but yeah, like primarily um looking at patterns and seeing what comes up, and the easiest way to generate patterns is with the computer nowadays.
Yeah, that makes more sense. That's really cool image that you shared. Thank you so much for that. And you explained it really well. Thank you. Do we have any last questions? Last minute questions from chat? If you guys want to ask any more last minute questions, you're more than welcome to. You can write it in chat or use the toxic drop points. It doesn't matter too much now. Um, just drawing shapes over and over again. That's the way I would have done it, Jimmy. I would have sat down and I
Yeah.
would have cut this out in pieces of papers and I would have just, done it over and over again. Is this something that you'd be interested in, Stucky, in future to be a part of a project or like if you were to do research because you were kind of saying that from what I understand, it wasn't research exactly that broke your heart. It was like the academic sphere, right? But if you were to, like, you got billions of funding right now, you could do whatever you want. What kind of field would you do?
I mean, honestly, I'd probably like I would shift my focus in algebraic combinatorics a little bit. But like, yeah, I mean, I'm currently working on a project, which is uh, right now we don't understand it well enough for me to explain it. But like really, like that's the thing. It's like when the research is in progress, it's the words to describe it don't really exist.
Mm,
And that's part of what makes math research difficult.
mm,
So yeah, but somehow there's some polynomial algebra hanging around in the background, and um, yeah, I mean, I think tilings are pretty awesome. I don't know what there is like what the big questions are nowadays. Um,
mm,
so uh, I don't like currently have the motivation like, oh, that would be a really interesting thing to think about.
mm.
Um, but I could very easily see myself falling into that sphere if some problem catches my eye.
So, so a question was asked and I ignored it earlier because it was just for banter and for jokes, but it was re-asked because it was so, like, clearly people got to know in the chat. How do you make your hair so voluminous and so gorgeous and so beautiful? Please share your
Uh,
secrets.
my secrets are I don't use any product that's like I don't do anything to maintain my hair.
Damn it.
It's yeah. I wish I had the secret to good hair to give you, but it's
Genetics is the
unfortunately it's
answer,
just
team.
yeah.
Genetics. Damn it. The heartbreaking answer to that question, unfortunately. Well, Stucky, thank you so much for coming on the show. Honestly, it was actually so interesting to talk to you about maths. Even like just outside of your research, the fact that I like the questions about infinity and obviously symmetry and the other things that we talked about. It was so interesting to hear you speak about them in the way that you did. I know that sounds kind of almost backhanded, and I don't mean it in that way,
No, no.
but it's a really interesting separate thought process that you have. Because again, I did cover a lot of these stuff, all of these concepts, I, infinity, everything, but obviously as a physicist, I think of them in different ways.
For
And
sure,
so
yeah.
it's so insightful and informative to me. So thank you so much for coming on the show. Would you like to say anything? You said you wanted to give shout outs. You're more than welcome to.
Yeah.
The Twitch was linked in the chat. We're more than welcome for that link to be shared again.
Hmm.
If you want your Discord shared or anything like that, of course, as always. But Stucky's name is in the title chat, by the way, if you guys want to check their Twitch out. Would you be streaming later on Twitch today?
Yes, I am.
Oh, there we go. There we go.
In about an hour, I think.
And did you hear that, chat? In an hour, in an hour. So if you guys have more questions for Stucky, make sure to ask on their Twitch stream. Sorry, would you like to say anything towards the end? I probably spoke
Yeah,
over.
you're good. You're good. So I already mentioned Danny and Zach. There's sort of this community that have been calling ourselves the Twitch math department. So big shout out to these folks, Penn Center in particular for sort of bringing me into the fold. Um, uh, yeah, Don does math is another guy. Spends a lot of time answering questions on Reddit. Um, although yeah, I mean, like he's a grinder. I'm really impressed by the amount that he manages to get done in a
Damn,
stream.
damn. Reddit is a minefield. Like, oh wow, that's impressive.
Um, a couple of folks who like really center their streams around talking for viewers is actual education. Even goes beyond math, like focusing more, I think, on like the K-12 on the pre-college level stuff.
Hmm.
Um, and then also newer to the scene. So I really but a good friend of the stream, so I want to shout him out. Is Everyone Loves Math.
That's a
Um,
good name.
yeah. Yes. It's a self-fulfilling prophecy, right?
Mm. Perfect. Thank you so much. Is that sorry? Was that everyone?
So I want to do one more
Okay, one more. Sorry.
quick round, which is big shout out especially in honor of this being Women's History Month. I want to shout out the women and the gender minoritized folks in the community. Primarily Phobos Stream, who is
In the
a
chat.
software dev who is working on. Yeah, I saw her earlier. Um, who is and also like working on their GRE, so their entrance exams. And check out Subway 500BWAY, who is going to start streaming again later this month. Took a small break. Some folks who are adjacent, Globular Goblin is a good friend of mine. We actually met offline a long time ago. That's a funky story. Um, and who does like Pomodoro, these like productivity, and has amazing taste in music. So uh, I put her on often when I need to get stuff done and I'm not on camera. But that's I'll cut it off there.
That's perfect. Well, the final shout out is to you, of course. Again, thank you so much for coming. Really appreciate it. I hope my community learned something today. Isn't that right, chat? I always finish my science and tech segments with asking chat what they learned. It's never what was actually the main topic, of course. It was always some sexual comment or some bad joke or something. Isn't that right, chat? Isn't that right? Don't embarrass me, chat, now and say something bad in the chat.
Oh,
But
I've
again,
been there for these conversations. I know how it goes.
57 is the best prime number, is what everyone learned. I love that that's what everyone learned. That's brilliant. Again, Gurvmila Mahakats for coming on the show. Really appreciate it. I am just chat. I'm going to continue streaming science and tech. I'm going to hang out with you guys and talk, but I will go into the ad scene just so that I can say my farewells privately to Stucky. So say goodbye, everyone. Bye
Bye, chat.
bye.